Mic check 1, 2. Wicka, 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 wicka. Mr. Catlin here, laying down your homework help for lesson 15, the volume of a cone, as we look into the cool down to calculate volumes of two figures. Now let's read this problem. This problem says we got a cone that has the same base, but a height 3 times taller than the given cylinder that we see over here to the right. So what is the volume of each figure? Express your answers, express yourself in answers in terms of pi. So we're going to keep it in terms of pi. Keep it real cool like. Now, if we look at this particular cylinder right here, we're trying to find out how much volume is inside of it, but we're also comparing it to a cone that has the same base, but it's 3 times taller. So let's find the volume of each, and then we can make a comparison between the two. Let's start with the cylinder. The cylinder can be found. The volume can be found by using the formula for a cylinder, which is pi times a radius squared times height. We have everything we need. We've got the radius right here. We've got the height right here. So we can plug those numbers in. Pi times our radius, which is 3, getting squared, times our height, which is 4. 3 squared is 9. Not 3 times 2, 3 times 3. And then 4 times 9 is 36. So we get 36 pi. And it wants it to express ourselves in terms of pi. So we're going to leave it as 36 pi units cubed for the volume of the cylinder. Now, we also have a cone that shares the same shape on the base, same size, shape, the circle as the cylinder does. So I'm going to try to replicate it as best as I can. So this is like the same as that right there. Now, its height is different though. It's not 4 units tall, it's 3 times taller. So 3 times taller than 4 means that I'm going to have a cone that has a height. I'm going to sketch it over here, nice and beautiful in my green color. It's going to have a height of 12 because that is 3 times taller than the 4 that's over here in the cylinder. But its radius is the same as what we saw over here, having a radius of 3. So, height of 12, radius of 3. How do we find its volume? Well, we have a formula for that. That formula is the same as the cylinder one, pi r squared times height. But since it takes 3 cones to fill that up of the same base and height, we have to divide it by 3. All right? And we're going to see, because of that division by 3, there's going to be a pretty common answer here. If we put in our radius of 3, we've got pi times the radius of 3 getting squared. We put in our height of 12, and we put in our base, our division of 3. It's already there. Excuse me. And we work this out. So we do our exponent first, and let's work it out this way. We got pi, 3 squared is 9, 12, and 3 still there. We're going to do 9 times 12, which is pi times 108 divided by 3. Now we got to do 108 divided by 3, which actually turns out to be, once again, 36 pi. We got the same answer as we did as the cylinder. Now, why did that happen? Why did the cylinder and the cone, even though this one was taller, actually have the same volume? Well, the reason is because it was 3 times taller. So if it's 3 times taller, then it's going to have 3 times volume, but we have to divide by 3 because it takes 3 of those cones to fill up the same size cylinder. It's kicking me offline, so that's my time to go, but both of them equal 36 pi units cubed, and I will see you guys on the flippity flip. Later.